Hello and welcome to this video where I'm going to try to help you see the link between geometric sequences and series, which is our next section, and the paper folding activity we did on Friday. So we started off, and I'm going to base it on the main piece of paper, the standard one, which has a thickness at about 0.1 millimeters. Now, what happened? Well, we started with this piece of paper of 0.1 millimeters and we folded it in half. So if you see it, it now has an overall total thickness of 0.2. Once I fold it again, let's take a look now, this would be something like this, approximately. Now the total thickness of that is going to be 0.4, and it's easy to see that once I fold it again, the new thickness will be 0.8, because I'm just doubling the thickness each time, and then 1.6, and so on. And of course, I want you to realize that what keeps happening, as I said, is that I'm doubling the thickness. So each time, to calculate the thickness of the next step, I have to multiply times 2, and that's how I get the new thickness. Now, this is what you were doing. And the interesting thing is that you had two pieces of paper, one standard one and one that was bigger and thinner. Now, how come you couldn't just get to double, like, you know, this one here you could only like fold it about 7 times, and the other one maybe one more time, but not double the times? How come? That's a very important thing. That's something that relates very strongly with geometric sequences and series. Now let's analyze this a bit further. Now this is roughly what it looked like. Now my original thickness is over here of 0.1. That's my original thickness, 0.1. This one is going to be 0.1 times 2. Here I'm going to have 0.1 times 2, which is the previous one, and I double it because I'm folding it. This one's going to be 0.1 times 2 times 2 times 2, and so on. So what really is going on is that I'm multiplying times 2 a number of times. Now how many times? Let me finish this one here. Times 2 times 2 times 2. Now in this one, in the very top one, I'm multiplying times 2 0 times, no times at all. That's the first level. That's the first stage, the first situation I'm in. A paper of 0.1 millimeters has a thickness of 0.1 millimeters when I don't fold it any times, when I fold it 0 times. So that's why actually I could put right here times 2 to the power of 0. Here I'm going to have the next section times 2 to the power of 1. Here really I'm going to have 0.1 times 2 to the power of 2. Let me write this down here in a different color. Here I have 0.1 times 2 to the power of 0. Here I have 0.1 times 2 to the power of 1. Here I have 0.1 times 2 to the power of 2. 0.1 times 2 to the power of 3. 1 times 2 to the power of 4, 0.1 times 2 to the power of 5, and this goes on. So when I fold it 0 times, my thickness is 0.1. When I fold it 1 time, my thickness is 0.2. When I fold it 2 times, my thickness is 0.4. Now, if we think of this as a sequence, it's interesting to remember the system we developed to name these sequences. This would be stage 1 of the sequence. Let's call it A1. For sequence A, first level, second level, third level, fourth level, fifth level, sixth level. So realize, when I have a 1 here, I get a 0 here. When I have a 2 here, I get a 1 here. When I have a 3, I get a 2. When I get a 4, I get a 3. The first original thickness is always the same. And as the folds carry on, this number keeps growing 1. Can you see the pattern? Look at it carefully. I'm about to slide to the next one, and I'm going to show you the general nth term formula. The one that allows me to calculate the thickness at any level using a formula. Well, here it is. This is the nth term formula of my paper that I'm folding. And let's analyze it quickly. What's happening here? Well, what's happening here in my piece of paper, for example, A3, that's my thickness in level 3. 0.1 times 2 to the power of 3 minus 1, and that's going to be 0.4. So my level 3, which is after folding 2 times, has an overall thickness of 0.4. So why can't I fold it 10 times? Why can't I fold this piece of paper 10 times? Let's figure out the thickness. 0.1 multiplied times 2 to the power of 10 minus 1. That's equal to 0.1 times 2 to the power of 9. And actually, this is 512. And 512, that would mean 512 thickness of pieces of paper. That's exactly the same thickness than those packets of pages that you get when you go buy, I don't know, like paper for your photocopier or your printer, and you get those packets in the supermarket of 500 pages. That's the thickness of this. That's 500 pages stacked together. Try folding that. That's huge. That's really thick. You can't fold that. It's like a chunk of wood. You can't fold that thing. Which is why we can't fold a piece of paper 9 times. It's crazy. It's super thick. And even if you have the old, like even if we're doing it, let's have this be sequence B, folding it 100 times. Sorry, not 100, that'd be too many. Let's do it 10 times. But I'm going to do it 10 times with the thin piece of paper. Suppose that the thin one had a thickness of 0.02, which I'm sure is actually not the case. I'm sure it's actually thicker than that. But if I have 0.02 times 512, that also has a big thickness. That will have a thickness of about 1 centimeter. This is equal to 10.24 millimeters. That's, well, 10 millimeters is about a centimeter. A centimeter is thick. That's a thick thing. You can't just fold that. So even the very thin piece of paper, folding it 9 times, is crazy. It's very difficult. Now understand, please reflect on the implications of this. This system where I just multiply times 2, times 2, times 2, times 2, degenerates in huge numbers very quickly. That's why I can't fold a piece of paper any further. Now let's generalize a little bit. Here is the general formula for geometric sequences and series. In the one that I had, the first term, A1, was my original thickness, and then I was multiplying times 2 and minus 1. And 2 was my ratio. That's how we call it. Ratio. The number I keep multiplying by. If I have another type of geometric sequence, for example, 6, 12, 24, you can easily see that I multiply times 2 to go to the next term. So my ratio in this case would also be 2, but my first term would be 6. So the nth term of this sequence would be 6 times 2 and minus 1. In this one, for example, 2, 6, 18, my first term would be a 2, and my ratio would be 3, because that's the number I multiply by to move on to the next term. This is how geometric sequences and series work. Now, before we go, I want to just say a few words about some things I heard in class. I heard you guys say, when I asked you, how do you know? A lot of you told me things like, I saw it on the internet, or I watched a video about this, or a friend told me. That was interesting, because that's great. I mean, there's nothing wrong with like knowing things because you saw it on the internet or your friend told you. But think about what we just did. We proved it. We kind of saw how it mathematically behaves. How does that change your knowledge of why you now know that it's so hard to fold a piece of paper 7 or 8 or 9 times? Is it mysterious why that happens, or is it not mysterious anymore? How has that changed? Please think about it. This is interesting. Anyway, thank you very much for watching, and I'll see you in class next time. Bye!